Okay, welcome back. Happy Wednesday. Today, lesson number 21. Okay, so a couple of things going on today. So first, I just handed back quiz number 2. I do want to talk about the trig question. So we're going to spend a few minutes at the start of our class going over how to handle part of that trig question. Again, the quizzes are supposed to be this really like low stakes way to get feedback heading into the test. The quiz is worth 0.8% of your grade at the end of the semester. The more important thing than the number at the top is the sense of where you are. We've got a test number 2 coming up. That one's worth a whole heck of a lot more than this quiz. Speaking of quizzes, quiz number 3 is due right now. So go ahead and put all of your attempts for quiz number 3 in the green folder. This was the derivatives memorization thing. So go ahead and throw that in the green folder for me. Coming up, let's see, well, today we're going to talk about inverse functions and log functions. This is a pre-calc review day, no calculus here. But coming up on Friday, the steel drum project is due. And coming up on Monday, the pipeline project is due, okay? So I know folks are working hard on these. Keep on trucking and turn these 2 things in on time if you can. Test number 2 is not too far away, November 3rd. I think we figured out that was Friday next week. Yeah, next Friday. I think it's Friday. Yeah. Okay, questions on the calendar? All right, so I said that I wanted to talk about part of the quiz. So there was one trig question on this quiz. It was about the, I don't know, it was like a river going up and down or an ocean or something, I don't know, some tidal thing. And it said like, when are the times, who's got this thing handy? When are the times when the water level will be at -8 feet. Okay, so I'm answering a slightly different question. On your quiz, you should have had like a -8 right here equals to the trig equation. I've just changed it to -13. I'm trying to make it a little bit messier than the quiz question. Also, many of you on the quiz avoided having to shift horizontally by putting a negative in the front. Totally good. I'm going to solve a more complicated equation than the one that you had just so that you can handle it in any case. This is as complicated as they come. So even if you didn't have this equation on your quiz, if you could go ahead and on page 50, write that equation. We've got space here on page 50 to do this problem all the way out. And so the reason that I want to do this problem is that I feel like I didn't do a good enough job with putting you in a good spot to solve trig equations. It turns out there are a bunch of different valid ways to solve equations just like this. And I kind of showed you guys one way together in the demo a couple of classes ago. And then in the activity, I kind of showed some tables a different way. I wasn't really all in on any one way. And so even though there's all these different valid ways, I'm going to go all in on one way. You can solve this equation in a number of ways, but I just want to sort of say, hey, if you want to follow my lead, this is what I recommend. So the beginning part, nothing tricky. We're going to isolate this sign business. So we need to move the -12 and the 8 in that order. So we'll add 12 to both sides. So I guess that's a -1 equals. And then we'll move the 8 over by dividing. So -1/8 equals sine of all this gobbledygook. Okay, so here's the first tricky moment. At some point, we're going to use our calculators. What are we going to do to both sides of this equation? We're going to do inverse sine. And so we're going to have to do the calculator. But let's go ahead and put inverse sine in front of both sides. So inverse sine of -1/8 equals inverse sine of all of the right-hand side. Okay, and I've written this thing out on the right-hand side, even though lots of stuff disappears. What does the right-hand side become? just this pi over 6 t minus 6 part, right? Like that's why we put the inverse sign there, was to cancel. So I just want to point out two mistakes that I saw from a couple of folks. I saw one person try to divide both sides by sign. Sign is not a number by itself. Like sign isn't a thing you can just divide by. You could divide by sign of x or by sign of 17, but you can't just divide by sign. That will not move the sign over to the other side. Inverse sign is the way to do it. The other thing I want to point out is that a couple of people just sort of notationally did something I don't want to see, and they didn't have enough room to put the inverse sign there in the front, and so they tacked it on the back. But it needs to be in the front. It's inverse sign of the thing, okay? So give yourself space, put it in the front. I didn't take any points off, but this does not have any meaning here. Inverse sign needs to be in the front. Okay, so far so good. Before we go to the calculator, this is now the new thing where I'm saying, hey, follow my lead. Let's solve these equations this way. Let's go ahead and draw our friend the unit circle. And in this case, we were looking for a point where the sign value was -1/8. Now, just so that we can think of this maybe in a slightly easier way, I will translate that to a decimal. You don't need to do that. We're just going to type -1/8 on the calculator, but it's -0.125. That's what the decimal value is of -1/8. And I will also ask on the unit circle, is the sign the x or the y? It is the y. And so this is looking for an angle where the y value is -0.125. And so we are just looking at the circle, and we are looking for points on the circle where the y value is -0.125. So for example, if I'm up here in this first quadrant, am I going to find any y values that are -0.125? No. If I'm in this quadrant, am I going to find any y values that are -0.125? No. We got to be down below. And so down below, remember, this is a -1 here at the bottom, so I guess -0.125 is, I don't know, maybe up there somewhere. Is that fair? Right, like right around there, maybe. Yeah, I think that's good enough. And how many points do you see on the unit circle that have that exact y value? There are two. There's one way over here, just horizontally, and then one way over here, continuing this way. So we've got these two winning points, and so I will draw in a ray from the origin to each of my winning points. There's one. And so the angle that we are going to get, one of the angles we're going to get is that one, going from blue to blue. And then the other one we'll draw in green. It is here down to there. And it's that big angle right there, okay? This is not how I presented things the other day, but this is how I'm thinking we should head from this point forward. We're going to type inverse sign on the calculator right now. It is going to give us only one of those possible angles, but we need to use the symmetry of that unit circle to find the other angle. So on the calculator, here we go. You don't need to type it on your own. It's not all that hard to type. Inverse sign of -1/8. Before I hit enter, what should I check? I need to be in the right mode, and we are not. But it's really easy to miss that. I mean, the calculator is going to give you a messy number regardless of what mode you're in. And so if you're not on the ball, I don't know, I can't really tell that one of them is wrong. They both look like the same amount of messiness, but the bottom one is a degree angle, and the top one is the one that we want. Okay. All right, so we've got that top answer. We'll go back to radian mode here. And I will write this guy down to the nearest, I don't know, come on in. We'll write that one down to the nearest thousandth, we'll go. Okay, so what we have discovered is that one of these two angles, either blue or green, is -0.125 radians. It is negative, which means we are going which way, clockwise or counterclockwise? This is clockwise. Negative angles go clockwise, positives go counterclockwise. So what angle did we find? Well, we found green, but we found green not going the long way. Rather, we found green going the short way, which is not what I drew in there. It's okay. So -0.125-ish is the value of that green angle going the short way. What that means, if we label our picture, let's go right here. This angle right here is -0.125-ish. And then thinking about symmetry, I guess that means that the space in here is the same, right? It's also negative 0.12. Well, I guess if I'm just calling the space, I'll call it positive 0.125. Is that angle, right? Negative, positive, doesn't matter to me. That's the size of that angle. It's about 0.125 radians. And so if I want to make sure that I write down my two fundamental angles, well, I guess I've got green here as negative 0.125, and that's fine. If you wanted to actually find the green that I calculated, you'd add 2 pi to this thing, but you don't need to. But if I wanted to find blue, what would I do to find blue? Yeah, pi is the halfway, and then plus this 0.125, yeah? Okay, so those are our two angles. So I'm going to call them the two fundamental angles. We had negative 0.125, and the negative is important there. And then pi plus 0.125, and it's important that that is a positive. Just thinking about the geometry of the picture. Okay, somebody with a calculator could maybe get us this guy. So that was like, yeah. Say again? 3.0 is no good. 3.267. 3.267. Okay, those are our two fundamental angles, negative 0.125 and 3.267. And so what does that mean? Are these the values of t? No, we're not quite at t. What these are the values of is this thing inside here. The angle sitting inside of there is negative 0.125 or 3.267, right? Those are the things that are equal to what's in the parentheses. And so we're going to write two separate equations, which we will solve. Pi over 6 times t minus 6 equals the first angle. And then the same thing, pi over 6 times t minus 6 equals the second angle. And then we will unpack that algebra to get our hands on the t, okay? But we don't have to get distracted by that. The unit circle is quite happy just thinking about the basic angle, which is what's inside of the sign there. Additionally, I said that there were two fundamental angles, blue and green, but really there's infinitely many angles if we just keep wrapping around however many times we want in whichever order we want. And so then the last technique is to say, okay, negative 0.125 is one part of that family, and then we can add any number of 2 pi's and still get, so you could do 2 pi minus, I'm going to do plus 2 pi n, it's just going to be my default, but yeah. So to get from 1 to all, we just add 2 pi n at the end. So negative 0.125 plus 2 pi n, that's 1, and then 3.267 plus 2 pi n, that's the other. N is just supposed to be an arbitrary integer. For example, if n is 17, that's just saying we're going to one of the angles after we wrap around 17 complete times. And if n is negative 5, we just go the other direction 5 complete times before finishing off at our angle. Exactly, just how many times you wrap around. Okay, so then I think that's good. So now we're ready to get our highlighted stuff in here. So either pi over 6 times t minus 6 equals the one of them, or pi over 6 times t minus 6 equals the other one. Okay, so now let's finish. I don't know if there's enough room on your page for this, but if you just look at the bottom, push the extend page button, you get more. Thank you. Yeah. All right, so trying to get the t by itself. So let's, instead of dividing by pi over 6, let's multiply by the reciprocal. So this becomes t minus 6 equals negative 0.125 plus 2 pi n, the whole thing times 6 over pi. Okay, so reciprocal on both sides. Let's distribute that 6 over pi. Somebody with a calculator, 6 over pi times this negative 0.125. The rest of us are going to do the 6 over pi times the other term. The 6 times the 2, that's a 12. What happens with the pi's? They cancel, right? Pi over pi, that goes away. So it's going to be a plus 12n sitting there at the end. Anybody have a number for us? Okay, that seems reasonable to me. Just pausing here for 1 second. Do you guys remember the period of the function on the quiz? It was 12. That plus 12n is accounting for the fact that you can just go over any multiple of 12, but we don't have to think about it. It just happens. Okay, and then finally add 6 to both sides, and the 6 will just tack on to the negative 0.238. So I don't know, 5.762. Is that all right? Just check me on that one. And there you go. That's an infinite family of solutions to our equation. You pick any integer n that you wish, plug it in, and you will have a solution. And so for example, if I'm over here and I just do, here we go, 5.762 plus 12 times nothing. Okay, well, that's silly. That's one answer, 5.7 hours after the start of this experiment. I don't remember if it was midnight or noon or whatever. Or I could say times 1 and get another answer, or I could say times 2 and get another answer and get as many answers as I need. And so if I force your hand and I say, give me all the answers between like 40 and 50, you just hunt around until you find them, right? I haven't found them yet. So what should I do next? 3. All right, are we between 40 and 50? You bet. If we go one more, are we still going to be between 40 and 50? I think we're going to be 12 more, which is outside. So there you go. 41.762 is the only answer between 40 and 50. There could have been more than one. Just depends on how big the interval is that I give you. That is one answer. The same technique will get you another family of answers over on this side. And again, you play the same game, 1, 2, 3, 4, and just find the winners, okay? So this is my recommendation. Like I said, there are a lot of ways to do this. This is not how we did this when we did our pre-calc trig review day, but this is my suggestion going forward for solving equations like that. Carrie? Do you mind sending? Oh, I can do that. Sure. Okay, any other questions on this one? Does that feel okay? Yes, nod your heads. Yes, yes. This is wonderful, Ian. Yes. Okay. All right. So that is all I wanted to say about that. Let's go back now to page 45. Okay, here we go on page 45. It says today we review inverse functions. More specifically, we'll look at log functions as inverses of exponential functions. This review will help us discover derivative formulas for inverse functions, including log functions next class. So that's where we're headed, derivative of log, derivative of ln. That's where we're going next class. This is an AP question. We're going to skip it just because I spent a long time on the trig thing. But in any event, if you want to find the inverse function, like as a rule, you guys remember this process from, I don't know, maybe college algebra? What's the first step? Is you swap, right, the x and the y, change rules. And then you solve your new equation for what letter? For the y, which is going to be buried. And so I will just write the new equation. The y becomes an x. Both of those x's become y's. And then you solve for y. And whatever you get will be your formula for f inverse, okay? So that's an old process. We're not going to do the algebra now, but you can try that later. Okay, but what I really want to make sure we're solid with today is logs. So here in number 2, let's do know what these statements mean. So y equals log base b of x means b raised to the y power equals x. And so for me, this is just like a diagram. That to that, cross the equal sign, equals that. So every single log equation has this corresponding exponential equation. It is just a straight up definition. Just have to know where the pieces go. We do have 2 special bases that we focus our attention on typically. If it says log x and there's no base written, what's implied? 10. And so that means that this equation, following the same pattern and putting an invisible 10 in there, 10 to the y equals x. And then finally, if you see ln, what's the implied base? Is base e. So that number is around 2.7, and that is the base. And so this one becomes e to the y equals x. So this is just definitions of logs, and without like playing with numbers, it's just like symbolic manipulation that doesn't have a lot of meaning. And so I'd really love, without a calculator, for us to be able to estimate log of 800. Like if you type log of 800 in a calculator, which we will in just a minute, but don't do it now, you'll get a number. And I want us to be able to estimate what that number is. If we can't estimate the number, then we don't understand the most fundamental thing about logs. And when I first learned about logs, I did not understand the most fundamental thing about logs. I could do the properties all day. I could, there's like expanding properties and contracting properties, and I could use logs to solve equations, but I couldn't have estimated log of 800, not without a calculator. So let's make sure we can do this one. Suppose that we give this thing a name. Let's call it x. And then we translate this into the corresponding exponential equation. What is it? 10 to the x equals 800. That's the equation. Those two equations are one and the same, just two different ways to write the same thing. And so we just play the game. What if x is equal to 1? How much is the left-hand side? 10, right? 10 to the first is 10. What if x is 2? The left-hand side is 100. That's still too small. What if x is 3? 1,000. That's too big. So x is between 2 and 3. Yeah, that's it. That's it. It's just some number, some messy number between 2 and 3. Now 800 is pretty darn close to 1,000. So if I was a betting man, I would say closer to which one? Closer to 3, right? Because, I mean, it's not a linear thing, but probably 800 is pretty close. So, okay, so we're expecting like, 2.6, 2.7, 2. Something like that, right? Okay, so let's go ahead and type that on the calculator. So we're just doing log of 800. The calculator does have two built-in log buttons right there on the side for you. So we just type in log of 800, and we're expecting a high 2. That's pretty high too. Let's do it over here before we type it over here. If, as Ryan asks, we wanted to know what the natural log of 800 is. That's what you're asking, right? Yep. So then we translate. What does this become? E to the x equals 800. Okay, so this one, it's just a little bit trickier because the powers of e are not as natural for us as the powers of 10, but we can still think about it. E is, we'll just call it 3. Close enough, it's a little bit less than 3. So 3 to the first, 3 to the second, 3 to the third. We just got to keep going. 3, 9, 27, 81, 3 to the fifth, that's 243. Big enough? Not big enough. 3 to the 6th, 729. Big enough? No. But between what and what are we expecting now? 6 and 7. Closer to which one? 6. Closer to 6. 800 is not that far from where we are. Okay, so if we type in ln of 800, we are expecting something between 6 and 7, probably close to 6. Now, before I type in and see whether or not we're actually right, now it's 800, I will point out, these were not the powers of e. What were these the powers of? 3. That was just to make my life easier. So because 729 is close to 800, I can't even say with 100% confidence that what we just predicted is going to be right. But we thought a little bigger than 6. Let's see. Okay. Right. But it turned out to be closer than 7. Closer to 7. Okay. So if we understand what we just done up here, then there should be some equation that should be easy popping out of this. So for example, if I asked you, so we've discovered here that that this turned out to be, what was it, 2.9-ish? Okay. So then I will ask you, if we did 10 to the 2.9 and some more change, what should we get? We should get 800. That's the magic number. That's the power on 10 that will give us exactly 800. So if I do 10 to the 2.9, is that going to be exactly 800? No, because 2.9 was not the right answer, but yeah, we're close. So if I really want to do this right, I go back to my log of 800, and then I say 10 to the second answer. This one is 800. Okay, so log equations, exponential equations, they're exactly the same as each other. Two different ways. It's like two sides of the same coin. Okay, what's the relationship between f of x equals e to the x and g of x equals ln of x? They are inverses of each other. Fantastic. They undo each other in a very specific way, which we will see on the next page. Five, what's the relationship between the graphs of two functions that are inverses of each other? Their coordinates are swapped. That is correct. That's the very first thing we did up above, was we changed x and y. Symmetric over what? It's not over the x-axis. What is it? Yeah, symmetric over that 45-degree line, y equals x. When you swap the x and the y, if you just plot a point and you swap the x and y and plot the new point, you're just going right across this diagonal line, y equals x. So let's see that in practice on the next page. So it says we're going to sketch e to the x, and we're going to sketch ln of x on the same axes here. And so we'll try to do this pretty quick. F of x equals e to the x. Okay, so I'm going to do -2, -1, 0, 1, and 2. Okay, I'm going to start in the middle because that's the easiest thing to do. E to the 0. Remember, e is around 2.7, but anything to the 0 is 1, so that one's fine. And then if I plug 1 in, I get e to the 1, which is right around 2.7. All right, and if I plug 2 in, so now we're going to get the calculators to help. I've seen this one so many times. I should just memorize it. I think it's like 7.89, but I don't know. Somebody give me e squared. What is it? What is it? 7.4? Okay. All right, and then up here, e to the -1, that's really just a 1 over e. 1 over 2.7, somebody with a calculator? 0.37, we'll call that 0.4. And then e to the -2. What is it? 0.14, okay. So let's go ahead and plot our 5 points. I'll start in the middle. 0, 1, that's right there. 1, 2.7, that's roughly there. 2, 7.4. 7.4, maybe there. And then plot 2 more points to the left. So -1.4, and then it gets hard. -2 to the 0.1, that's just a little bit above the x-axis. And then we connect the dots, right? We knew e to the x was going to be an exponential growth curve. It gets really close to, but never touches the x-axis. Okay, so we're really familiar with the graph of e to the x. But a lot of us are not near as familiar with the graph of ln of x, and I want us to get really comfortable with the graph of ln of x. And so I'm ready to plot 5 points. In fact, I've got 5 points. What am I going to do to find the corresponding points on ln? Switch them, right? X and Y swap. Again, in that example that we skipped over, this first step we do is swap X and Y. So the first point here is 0.14 for the X and -2 for the Y. Find it. 0.14, a little bit to the right, -2. What color are we here? Blue is fine. Right there, just slightly to the right of the Y-axis. And then swap the X and the Y. 0.4, comma, -1. 0.4, -1, maybe there. What's the next point? 1, 0, that's the x-intercept. And then we go over to 2.7 and up 1. And then over 7.4 up to 2. Okay, and we connect the dots here. We've got this thing which is growing very, very slowly. Does it hit the y-axis? No, for the same reason that the e to the x doesn't ever hit the x-axis. This guy, its mirror partner in crime, never hits the y-axis. So really, really close, but never touching. Some students have the misconception that the log function has a horizontal asymptote. It grows really slowly. It does not have a horizontal asymptote. This orange function continues to go up and to the right, yes? Well, the black function will continue to go right and up. It's just doing exactly the same thing. And we know that exponential growth is really fast, which is why the log growth is really slow, but still growing. All the time grows. Okay, so this is the graph of ln of x, and I want you to be able to just know, hey, that's what the graph of the log function looks like. Okay, a couple of properties here. If you have log of a product, you can separate it into the sum of two logs. Log of a quotient becomes the difference of two logs. Log of a power, that power can come in the front. That is the most important of our 5 properties right there. And then we said that log and e were, ln and e to the x were inverse functions of each other. And so here's specifically what we mean by that. We mean that they cancel each other in this particular way. If you do ln of e to the x, the ln and e cancel and you just get back to x. And if you do them in the other order, the ln first and then take e and raise it to that power, they still cancel. We just get back to x. Okay, but the biggest purpose of logs for us, oh, also note there's no property for log of a plus b. See it? You cannot do anything with it, you leave it. But we're now in a position to solve equations where the variable is where? In the exponent. Logs is going to be the thing that opens the door for us. Okay, first we have to get the exponential part by itself. So move this 100 over. And by the way, this probably came out of some like money question. Like this looks to me like a 1 plus r over n to the nt kind of thing. I've seen that one before, right? R over n, so like some compound interest formula. And so it's like, you know, you had $100 and you get like 12% interest over the course of the year, but it's compounded monthly. How long does it take for the money to double from $100 to $200? Okay, so let's get that 200 out of the way by dividing. So we get this. And then we have to do something to both sides in order to free up the t. And dividing isn't going to do it. Sometimes people want to raise both sides to like the 1 over t. That's fine. That's fine. But the 1 over t would go up on as a power, right? Like the t is still a power. We need to do something fundamentally new, and the new thing is log. So we take the log of both sides. I will copy this thing just as it is with a little bit of space in front. And we will put ln here, and we will put ln here. And so when I say take the log, we could take the log with any base we want. It could be log base 49, could be log base 10. What base have we chosen? E. We're going to get the same answer for t at the end of the day, no matter what. But there's a very good reason that ln is going to be our favorite base. E is going to be our favorite base, and we'll see it next class when we do the derivatives of the logs. Okay, and then our power rule property up above says if you have a log of something to a power, where can you move that power? You can move that power right to the front. So let's do that. ln of 2 on this side. 12t, the whole thing comes down. ln of 1.01. I will put a multiplication dot just so we're clear. Yeah, and so you're going to go to the calculator at the end, but let's stay here without the calculator. We're just trying to get t by itself. 12 is a number, ln of 1.01 is a number. We're just dividing both sides by that whole thing in one fell swoop. So ln of 2 over 12 ln 1.01. Okay, and so we just make sure we type this in correctly. I'm going to make my guess here. I think it's around 6. I don't really know if I think it's a little bigger or a little smaller than 6, but 6 is my guess. Okay, so we type in ln of 2 divided by 12, ln 1.01. I was hoping something around 6. Oh, what is that very close to? That is not close to 6. This is 0.000574, nowhere near 6, right? That means times 10 to the negative 4. What did I do wrong when I typed this? Needed parentheses, right? Parentheses around that whole thing in the bottom. Okay, so let's try it again. Insert parentheses. So hopefully something around 6. All right. Around 5.8. So if the exponent is where the variable is, at some point you're taking a log. And let's just use ln. Okay? All right, let's move on to the next page where we'll find the activity. And because I took a lot more time with the trig thing, can I ask you to do these questions in reverse order? Can you start with number 5 on page 48 and then go back? Let's do everything on 48, and if you have time to then go back to 47, let's start with 48.